Welcome back, chemistry students. We're going to continue with our math unit, and some of you guys probably noticed in the last lesson that there were some questions with some calculations in them. And the last lesson's videos didn't cover those calculations because I was saving them for this week because I want to go into more depth on what unit elimination is and how it can help you basically streamline all of your chemistry math needs. This is what I used in university to do probably 90 to 95% of my calculations on when it came to assignments or labs or whatever the case is. Unit elimination is a really handy tool to have because it basically is a catch-all method for most chemistry calculations, but not every single one. The point of unit elimination, based on the name, is that it relies on the units of the values that you're dealing with. So that's why it's really important when you do one of these questions to write down all the information the question gives you and all the information that you can also get off the periodic table to figure out these calculations, which are essentially just conversions of one unit to another. And of course, as always, now that we're doing math stuff, we're going to have to use significant figures to properly round your final answer, but save sig figs for the very end, calculate as normal, and then round your final answer to the appropriate number of sig figs, which of course is equal to the least number of sig figs of all the numbers in the question. It should be pretty straightforward to figure out once you get a hang of it. Now, before we start, I want to show you basically how we can write one quantity in two different ways. Now this 18.0153 is the molar mass of water, H2O. Two hydrogens and oxygen create approximately that many grams per mole. In unit elimination, you want to write this quantity in one of these two ways. And it's important to note that these two different ways of writing it are equivalent to each other. Because molar mass is a ratio, we're able to just flip the fraction right over. As long as the numbers and the units go with the values that are flipping, then you can have it either with the 18.0153 grams on top and the 1 mole on the bottom, or you can flip it around and put 1 mole on the bottom and 18.0153 grams on the top. Now you'll notice that I've inserted a 1 in front of the mole, and that's because the unit on the molar mass of water is grams per mole. Now that grams is attached to the 18.0153. The mole basically means that 1 mole equals this many grams. So there's basically a hidden 1 on there, kind of like how we don't show a 1 on the term x. There's no point in putting it there because it's kind of redundant. And in this case, this is redundant as well. But we are going to put the 1 in front of the mole because it is going to help make these calculations make a little bit more sense, help the math at the end. All right, so on to a sample question. We're going to use the molar mass of water to basically calculate how many moles of water are in a 500 milliliter bottle. So like, a Nestle Pure Life bottle that you buy in the store. That's important to note that water has a density of 1, so 500 milliliters and 500 grams, same thing. So we're just going to assume that we're going to use the gram number here. We don't have anything to do with mils right now. I just put that in there because that's how water is listed on a bottle. So I got the 3 steps down here. We're going to start by writing down everything we know, and then I'm going to show you how to form an equation using the units of the things that you know. Once we're all done, the way that you build the equation is going to tell you what to do with the numbers, and it's always going to be multiplying and dividing. Sometimes you're only going to have multiplying, sometimes you're going to have to divide sometimes as well. So just be careful of where the numbers are, and you can figure it out pretty easily. So let's write down, first off, what I know. I know that I have 500 grams of water based on what the question has given me. And the only other thing I need in this question is the molar mass, which is 18.0153 grams per mole. Or, of course, a mole per 18.0153 grams. Now, I'm going to only need to use one of these two values. Okay? It's either going to be this one or this one. And interestingly enough, it's this unit grams here that is going to tell me which of the two forms of the molar mass that I'm going to use. Now, when you're forming your equation, the first thing you always want to do is write down the unit of the thing you're looking for. And in this case, I'm looking for how many moles there are. So I'm going to start by writing down moles equals. Now this basically tells me the goal that I'm trying to get to. I'm starting with 500 grams of water, right? That's the first quantity I'm given. Basically, this is how much water I have. I have 500 grams. In most cases, you're only ever going to have one quantity that has just kind of what I call a single unit. Whereas these ones here have 2 units, right? This 18.0153 is a gram per mole. It has 2 units attached. So we can't start with that. We have to start with a quantity that we know that has just one basic unit attached, 500 grams. Now, unit elimination is all about multiplication. And what I'm going to do is I'm going to multiply 500 grams by one of these two fractions. The fraction that I'm going to choose is the one that has grams in the denominator, in the bottom of the fraction. Because the whole point of unit elimination, and I'm going to put my 1 mole over 18.0153 grams. The point of unit elimination, as the name would suggest, is to eliminate the units, just like how a numerator and denominator of a fraction also eliminate themselves. Like, for instance, 9 over 3, the 3 gets eliminated by the 9, right? And you end up with a total of 3 left over, or you could write it 3 over 1 if you want. Unit elimination works on the same idea, but instead of eliminating numbers, which we're not going to do, there's not going to be any fractions like this in the unit that you guys have to worry about, so you can just get that out of your head if you're worried about it. What you're eliminating is the units on the numbers. And you can eliminate any unit in the top of numbers, including the quantity you start with any unit in the bottom of these fractions. So the reason I've chosen this one is because this grams and this grams eliminate each other. They basically cross out. Now, what I was trying to find was moles, and as you can see, that's the only unit I have left, right? This is my remaining unit. And in the question, I wrote down moles equals because this is the goal that I want to get to. I want my leftover unit to be moles, and according to this question, it is in fact moles. So my equation that I've built is now done. Now I just have to do the actual math, take the numbers, and figure out what the answer is. So it says multiply and divide values. Essentially, you want to multiply all of the numbers in the top of fractions, again, including your initial value, and divide that by all the numbers in the bottom of fractions, which in this case is 18.0153. Now you'll notice there's a 1 mole here. That 1 is essentially useless because multiplying by 1 doesn't do anything. So basically, you can ignore all of the 1s in the question if there are any there. So for this, basically all we need to do is our 500, and now we have to divide it by 18.0153. And if I get my calculator and do that here, I end up with 27.754, etc., etc., etc. moles. However, as I said earlier, your final answer should always be written with the correct number of significant figures. And in this question, the 500 here only has one significant figure. So I really have to round this to basically, well, I've got 27.75, so I'm going to have to round this to 30 moles. Because only one significant figure is allowed. And that's fair. The bottles of water don't necessarily have exactly 500 mils in them. It's kind of an estimation. So we have to give that same level of accuracy in our actual final answer. All right, that's it for this video. I'm going to, in the next one, go over a bunch of practice questions and different types of unit elimination you can do. We'll talk to you soon.